All right, so we finally have arrived at our final trigonometry lesson, lesson number 8, if you're following along in the packets, and on page 482 and 484 of the Larson if you're following through in the textbook. In this lesson, we're going to look at how to solve cosine x equals 1 plus sine x in a much more efficient manner than we have done in the past. Previously, we squared both sides, things got complicated, we introduced extraneous solutions. Today we're going to look at a way faster way to do this that is just much more efficient. We're also going to look at using that method that we learned in that first bullet point to graph the sum of trig functions. So here we have the square root of 3 times cosine 3x plus sine 3x plus 1. We're going to learn how to graph that. We know how to graph trigonometry functions when they're by themselves, but here we're going to learn how to graph the sum of trig functions, which is going to be kind of exciting. After that, we're going to solve the equation cosine 2x plus cosine 3x equals 0. Notice that the arguments there are different. We have 2x and we have 3x. We're going to learn how to solve these equations very fast. We solved this in a really slow way in one of my homework assignments as well as in office hours this past week, but I'm going to show you guys how to do it the arguably better way. And with that, we'll motivate a set of new formulas called the product to sum and sum to product formulas. And I will prove one of them, but I'm not going to prove all 8. I'll leave that to you guys if you want, but I will show you the 8 formulas. With that said, let's go ahead and solve cosine x equals 1 plus sine x in a very cool way. Get excited. Here we go. All right, so we got cosine x is equal to 1 plus sine x. So in the past, we squared both sides, raised a red flag because we need to solve for extraneous solutions, and then we just powered through it. I think some factoring happened. It was unpleasant. But here is a really cool little trick that you can use. So what I'm going to do is I'm going to move the sine x to the other side. All right, so we have cosine x minus sine x equals 1. And so why does this lesson come at the end? It has to do with what we've now learned since we solved this equation. So what has happened since then? We learned a bunch of identities. And this, if you think about it, kind of looks like one of our identities. It's kind of a stretch, but cosine, cosine, sine, sine, sine kind of have the sum and difference formula right here. The goal is how can I make that? So if you think about it, we need something here and something here so that we can generate that formula. I've given you guys problems in the past where you've solved things like right here. I asked you guys to solve this thing real quick. So we have cosine 4x, cosine pi over 7 minus sine 4x, sine pi over 7 equals, it was root 2 over 2. So this was number 5 in my problem set. Problem set number 2. And the way you solve this thing is cosine, cosine, sine, sine, sine. You just turn it into the cosine, cosine. This is going to be the sum of 4x and pi over 7. And cosine, cosine, that's going to be cosine, is equal to root 2 over 2. So this is something we solved in the past. So that is the method that we're going to use here. It would be great if we had some numbers here that I could use this. Now keep in mind also, cosine pi over 7, that is a number. And if you have an equation, there's nothing against the rules in introducing numbers as long as you maintain equality. So here's the clever move. If you haven't thought of it while I've been rambling and trying to justify this move, I'm going to multiply this entire equation by the square root of 2 over 2. What? Why is he doing that? All right, root 2 over 2 cosine x minus root 2 over 2 sine x equals, let's not forget the root 2 over 2 over here, right? Root 2 over 2 cosine x minus root 2 over 2 sine x equals root 2 over 2. We are now in this form, right? We have a function and a function, but we also have these two numbers. Like we up here, we had this number and this number. Sine pi over 7, that's like some number between 0 and 1. And sine pi over 7, that's some number between 0 and 1. So I'm going to rewrite root 2 over 2 as, what is that? That's cosine pi over 4. We are turning into my number 5 problem from my problem set number 2. Cosine pi over 4 cosine x minus, sorry. All right, cosine sine, that wouldn't help. But if I write root 2 over 2 as sine pi over 4, I think we're in business now. We can use the identity in reverse. We started with this green equation up here, cosine x equals 1 plus sine x, and instead of squaring, we just multiplied every element in this equation by root 2 over 2, and we have forced an identity, cosine, sine, sine. This is going to be cosine, first angle. We're doing the identity in reverse. Cosine pi over 4 plus x is equal to root 2 over 2. All right, so I'm going to finish solving this equation in the margins over here, but we're done. We just avoided all the perils of this equation back in the day. We had to square, check for extraneous solutions, factor. It was a miserable experience, but now all we have to do is solve cosine pi over 4 plus x is equal to root 2 over 2. When does cosine equal root 2 over 2? Well, we need pi over 4 plus x to be that. And it equals that in two spots, plus or minus pi over 4, correct? Plus 2 pi k. All right, the final answer is we need to subtract pi over 4. So I guess I'll write this, the final answer on the next page. But what do we got? Pi over 4 plus x is equal to plus or minus pi over 4 plus 2 pi k. Subtract 4 on both sides, and we get the final answer is, all right, I can't use the plus or minus anymore because positive pi over 4 minus pi over 4, that's going to be 0. So 2 pi k, 0 plus 2 pi k, and negative pi over 4 minus pi over 4, that's going to be a negative pi over 2 plus 2 pi k, and we're done. And if you go back and you look at your answer to this question, which we've certainly done before, it will be the same. And guess what? No extraneous solutions. When you did it before, you got some other annoying answer that you had to check and then cross out, but everything here works. All right, I highly suggest trying to implement this when you're solving trig equations in the future. I know our trig unit's coming to an end, but you know, there'll still be a little trig splashed here and there with the last things that we're going to do, but also calculus. Okay, well, that was awesome. All right, use that. Please, please, please use that. Let's go ahead and use it again to graph a function. We got the square root of 3 times cosine. Oops. We got the square root of 3 times cosine 3x plus sine 3x plus 1. My goal here now is to graph this thing. So we want to graph this thing. Sorry about this. Alrighty, so take a second to think about how you can use this strategy to graph this thing. Right, we are moments away, or seconds, milliseconds away from reverse identity. Right, using the identities that we memorized, that we learned, that we proved in reverse. We're just a fraction away. Take a second to pause and think about this. right? But I have a root 3 here. I'm going to go ahead and continue. I have a root 3 here. If I'm thinking unit circle, root 3, no good for me in terms of sines and cosines, but a root 3 divided by 2, I can work with that. So let's go ahead and force that. How can I get a root 3 divided by 2 here? Well, in a function, you cannot just, multiply by a number. Like, this is not an equation. This is a function. So what I need to do is simply manipulate the right-hand side. So fancy version of 1, I'm going to multiply by 2 over 2. This whole thing. Well, actually, not the whole thing, and you'll see why in a second. But I'm going to leave that 1 on the outside. That 1 can just go ahead and stay there. But if I introduce this 2 over 2, and if I go ahead and distribute just the denominator, I get root 3 over 2 cosine 3x. I get a 1/2. That works with the unit circle. And then once again, we're going to leave that 1 on the outside. And we are seconds away from reverse identity. So I got to think of a better name than reverse identity. But root 3 over 2, let's think. Do I want to use sine or cosine? It doesn't really matter. Let's go ahead and say root 3 over 2 is, that's the sine of pi over 3. And conveniently, 1/2 is the cosine of pi over 3. And then, that should be a 3x. We can use sine, cosine, cosine, sine in reverse. So let's go ahead and do it on the next page. We got a 2. All right, actually, I'll do it right here. Sine, cosine, cosine, sine. This is going to be sine pi over 3 plus 3x. Awesome. So if I jump to the next page, f of x is, we had a 2. Now we have a sine. Let me jump back. We have a sine pi over 3 plus 3x. And we have a plus 1. And this thing is very easy to graph. All right, yeah, you just have an amplitude of 2. You have a phase shift of pi over 3. You have a stretch of 3, and you have a vertical shift of 1. So I guess we could go and graph this. I'm actually not going to do it in this video. I'm trying to get better at graphing things on this software. But I mean, shift of 1, amplitude of 2. We have a pi. Ooh, I need to factor that out. 3 times, what is that going to be? X. And that pi over, is that 9? Yeah, 3 distributed pi over 9 is pi over 3. All right, so I have a shift of pi over 9 to the left. And then I have a stretch of 3. So it's going to look something like this. Oops. So, I mean, graph, you're good. You guys are good at that. We're not going to worry about that here. But I can turn the sum of trig functions into a singular trig function using this clever trick. All right, so what have we done so far? We have solved using this clever trick. We have graphed using this clever trick. We're going to move on from this trick. This video is all about just clever tricks. We're going to try to solve cosine 2x plus cosine 3x in a sneaky way. So let's go ahead and do that. All right, so how can we solve this thing? Previously, we used identities. We expanded. Cosine 2x became cosine squared x minus sine squared x, or something along those lines. But there is a better way, and I'm going to jump right into it. So it might not be obvious to think about this, but I want to use the sum and difference formulas on these things, but I want the arguments to be very similar. And here's a very clever way to make them the same. So if I rewrite 2x as 4x over 2. And I rewrite cosine 3x as cosine 6x over 2. Watch this. Cosine, I can write this as 5x minus x over 2. And I can write this one as 5x plus x over 2. Think about why that is going to be incredibly useful in a second. All right, like if you rewind to last week's problem set, we solved this thing. It took a while. There was some nasty factoring in it. But by rewriting 2x and 3x as half angle formulas, and then rewriting them again as the difference of 5x and x and the sum of 5x and x, formulas are going to be our friend. I'm going to rewrite all of these using the cosine difference formula. So let me make it completely clear. I'm going to rewrite this as 5x over 2 minus x over 2 plus cosine 5x over 2 plus x over 2. All right, I'm going to take this to the next page, but get ready for this. This is a wonderful trick, and it's going to justify some new formulas. Here we go. All right, I'm going to use the difference formulas for cosine. Here we go. So cosine, cosine, sine, sine, sine. So cosine 5x divided by 2. Cosine x divided by 2. Cosine, cosine, sine, sine, sine. So that's going to become a plus. And then sine 5x over 2. Sine x over 2. So that's the first formula. And then the second one, right? I'm going to have a cosine, cosine, sine, sine, sine. So plus cosine 5x over 2, cosine x over 2, but this time it's going to be a minus sine 5x over 2, sine x over 2, and that's all equal to 0. All right, did you see what happened? Look at what we have. We have a cosine 5x over 2, cosine x over 2, plus sine 5x over 2, sine x over 2, and we have a cosine 5x over 2, cosine x over 2, minus a sine 5x over 2, sine x over 2. These go away. All right, we just made our lives very easy. We have two cosine 5x over 2, cosine x over 2, and that's all equal to 0. All right, we have a product of cosines. We started with the sum of cosines. We now have a product of cosines. Why is that better? We can solve this immediately using the zero product property. All right, so we got cosine 5x over 2 is equal to 0, and cosine x over 2 is equal to 0. And all we got to do is solve these, and we're done. All right, so let's go ahead and do that. Cosine 5x over 2 is equal to 0. When is cosine 0? Cosine is 0 at pi over 2 plus pi k. And we need that thing to be 5x over 2. Multiply by 2 everywhere. I'm going to do this in as many steps as I need. 2 pi k, divide by 5, we get pi over 5 plus 2/5 pi k. Cool, that's one of our solutions. And then over here, when is cosine x over 2 equal to 0? X over 2 needs to be x over 2 needs to be pi over 2 plus pi k. And multiply by 2 everywhere, and we get pi plus 2 pi k. And there are our solutions to this equation. All right, we used what we call a sum to product formula. There is a formula that takes you straight from the beginning to this step that you can commit to memory or prove and reprove as many times as you want. But this is a nice little trick. Right? If I give you 2x and 3x, if you double them and then you rewrite the numerators as the same two objects, one a difference, one a sum, one a difference, one a sum. You can then apply some formulas, the easiest ones, cosine, cosine, sine, 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 and then ultimately solve this equation as a product rather than a sum, the sum to product formulas. And there you have it. So the last thing I'm going to do in this video, we've solved cosine x equals 1 plus sine x cleverly. We have graphed this function in a clever way. And then we solve this with our new sum to product formulas. I'm going to prove one set of the product to sum and sum to product formulas, and that is one of a set of 4. So there are 8 total formulas. I'm going to show you 2 of them, and then we're going to call it a day here on this video. So we're going to look at the product to sum and the sum to product formulae, sum product formulas. Okay, so to prove the formula that we just used, I'm going to start out with the sum and difference formulas. So cosine x plus y and cosine x minus y. So I'm going to start out with these things, and I'm going to write them out. So cosine x, cosine y, cosine, cosine, sine, sine, sine. And this is going to be the same thing, just with a different sign in the middle. All right, and if you pause the video and you think for a second, we can get the formula pretty quickly. If I want a formula for sum to product, I need to generate a sum. So I'm going to, over here, I'm going to add these 2 equations and see what happens. So I'm going to get cosine x plus y plus cosine x minus y. And in doing that, I'm going to add these. So I get 2 cosine x cosine y. And these disappear. Boom. All right, sine x sine y plus sine x, negative sine x sine y plus sine x sine y, that is 0. So if you notice, I have here the formula that I used in the previous problem. The sum becomes a product. The way we usually write this formula, this is the product to sum. We usually write it like this: cosine x, cosine y. The product of 2 cosine functions is equal to, divide both sides by 2, 1/2 cosine x plus y plus cosine x minus y. So this is our product to sum formula, and we are going to use this thing to prove the sum to product formula. So formula 1. Cool. So let's go ahead and look at the sum to product formula. So to do that, I am going to grab this thing. And we are going to use this formula here to prove our sum to product. So I want a formula that takes the sum of 2 arguments and then outputs a product. So I kind of have that right now, but it would be really nice if this was just one object and instead of an x and a y. I wish it was just one thing. I'm going to go ahead and say that x plus y is equal to a. So I'm going to have a cosine a plus, and I'm going to go ahead and say x minus y. I'm going to call that b. X minus y equals b. So I'm going to have cosine b, and I want to see how that turns into a product. I want my sum to product formula to have one object in the argument. All right, so all I need to do now is figure out what x and y is in terms of a and b, and then I'll have my formula. So x plus y equals a and x minus y equals b. So take a second to think about how you can figure out what x is in terms of a's and b's. We want to have 2 cosine something and something. So we need to figure out what goes in here in terms of a's and b's. What I'm going to do is, I'm talking slowly so you can pause and think about it. But what I'm going to do is I'm going to add these two equations. All right, these two equations are true. If I sum them, their result will also be true. So x plus y equals a, x minus y equals b. If I sum them, I get 2x. The y's go away, and I get a plus b. And then if I divide by 2, I get 2x equals a plus b. If I divide by 2, I get a plus b divided by 2. All right, so that is what goes in the x spot, a plus b divided by 2. And then same thing with y. How can I get a y? Well, if I subtract these two equations, I'm going to get x minus x, which is 0, y minus negative y, which is 2y. And I'm going to get a minus b. And then if I divide by 2, I get y is a minus b divided by 2. That's what goes right here. Cool. So this is our one of our 4 sum to product formulas. I'm taking the sum of 2 cosines. There's one for cosine plus sine. There's one for sine plus sine. And there's one for cosine minus cosine. And there's one for sine minus cosine, and so on and so forth. So you can go ahead and figure those out if you want. But here is our sum to product formula. All right. Let's real quick use this in the in that previous example that I did. So that previous example was cosine 2x plus cosine 3x equals 0. And what this formula says is, let's call this thing A, let's call this thing B. This becomes 2 cosine 2 cosine a plus b over 2 times cosine a minus b over 2. So 2x plus 3x over 2 and 2x minus 3x over 2. Right, and the cool thing is, if you jump back to previously in the video, this is exactly what we had before. Oh, actually, no, it's not. We have a negative x over 2. But does that matter? No. Cosine is even. So I can just go ahead and get rid of that x. That negative. And we're back to where we were before. So this equation should be very quickly solved if you use these new sets of formulas. Otherwise, you got to use the cosine double angle formula, the cosine triple angle formula, and then do a lot of factoring. So this avoids all that and turns it right into a product. 10 out of 10 would recommend. All right, so there you have it. The last video lesson of the trig unit. We revisited things that we already knew how to do, but we did them in a way more interesting, way cooler way. I just said way 10 times. So with that said, I'm going to close this video out. I hope that you learned something cool. And go ahead and shoot some things in the comments if you have any questions, or send me an email, or whatever you need to do to make sure that you understand this stuff. Have a great week.